Good afternoon, students. So today starts with actual topic, that is motion in a plane. Right. So what is plane? Plane consists of two coordinate systems. Right. So we have three rectangular coordinate systems. So out of these we can take any two. That is xy coordinates or yz coordinates or zx coordinate. Right. So here we prefer xy coordinate. So this combined we call as plane. That means an object which is moving in two dimensions. So two dimension means it uses two coordinate axes. So that's why the motion we call as two dimension motion. Right? So it uses two coordinate system. Hence we call that one as two dimension motion. It uses two coordinates. One is x and another one is y or yz or zx. Right? So first starts with position. Right? So take one coordinate system, that is xy. So y is along y-axis and x is along x-axis. These two represent what? The distance or displacement. So x and the distance, y and the distance. Don't confuse with this xt graph and bt graph. So xt graph, bt graph only along x-axis don't with time. So here along x-axis also we have the distance or displacement, and along y-axis also we have the distance. Right. So first consider one object. Right. So I consider this one as one object. So its position is at P. Right. So now how we define the position of this object? That is by the vector. So which vector we are going to use? Position vector. Right. That one is R. Now the position of the particle R, that is equals to, so by the component, so this one we taken as x naught, and along y-axis this distance is y naught. That means the object is at a distance x naught from the x-axis and y naught from the y-axis. Right? So that can be written as R is equals to, that is vector R is equals to x naught gap plus y naught j gap. So ಇದು ನಮ್ಮ ರೆಫರೆನ್ಸ್, ನೀವು ಏನು ಬೇಕಾದರೂ ತಗೋಬಹುದು, either x, x1, x2, x3. So starting ಇರೋದ್ರಿಂದ 0 ಇಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ರೆ that one x0 and this one is the y0. Right? So now after some time, so that time taken as delta t, small time. So in the small time this particle will cover some distance. Right? So now after some certain time the position of the particle is somewhere, calling that one as P dash. Right? So particle is there. So aduna ನಾವು represent ಮಾಡ್ತಿರೋದು position vector. That means we are representing in both along x axis and y axis. So ಸ್ವಲ್ಪ time ಆದ್ಮೇಲೆ ಈ particle ಏನಾಗಿದೆ, it covers some distance. So in such a way that it covers in along the x axis and also along y axis. So after certain time t, the particle is at P dash. Right? So now we need to find the displacement. So displacement find ಮಾಡಬೇಕು ಅಂದ್ರೆ in the second time also we need to find the position of the particle after t. Right? So again by drawing the position vector. So this one we call as r dash. Right? So p dash ಇರೋದ್ರಿಂದ r dash, p1 ಇತ್ತು ಅಂದ್ರೆ r1. Right? So now displacement. So displacement is the shortest distance between the initial point to the final point. Shortest distance between the final point to the initial point. So always that distance we taken in the straight line, that is joining the line joining between the two points. Right? So the displacement becomes this one. Right? So p dash gives what? The displacement vector. Right? So displacement p dash. So that is the vector. So in which direction we will take? So in the direction of motion. Right? So particle ಇಲ್ಲಿ ಇದೆ. So ಈ ಕಡೆ in the positive x axis or move ಆಗ್ತಿದೆ ಅಂದ್ರೆ displacement ಕೂಡ positive x axis. That's why I taken, so in this direction. Arrow mark represents what? The direction. So ಇದನ್ನ vector use ಮಾಡಿ ನಾವು simplify ಮಾಡ್ತಿರೋದ್ರಿಂದ ನಮಗೆ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಕೂಡ ಇಂಪಾರ್ಟೆಂಟ್, ಜೊತೆಗೆ ಡೈರೆಕ್ಷನ್ ಕೂಡ ಇಂಪಾರ್ಟೆಂಟ್, ರೈಟ್? ಸೊ ನಾವು if we observe here, we have vector r, that is position vector particle p. R dash is the position vector of a particle p dash. Here we are going to find the displacement vector p dash, right? So again by the triangle of vector addition, right? So r dash and p dash, so we calling this one as displacement vector, yes, right? So vector r and the vector s, these two represents the two sides of the triangle, right? Then r dash gives the resultant of the two vectors, right? So from triangle of addition we can write this one as vector r plus displacement vector, that is equals to vector r dash, right? So in ಯಾವ shape ಅಲ್ಲಿ ಇದೆ ನಮಗೆ, this is vector r, this is vector s, and the third one gives vector r dash, right? So these two represents the two sides of the triangle, then third side gives the resultant of the two vectors. So ನಮಗೆ ಬೇಕಾಗಿರೋದು ಯಾವುದು? Displacement vector, yes. So now shift this one, displacement vector s dash, that is equals to vector r dash minus vector r. So ಇಲ್ಲಿ ಸಿಗ್ತಾ ನಮಗೆ vector r dash is the final point, vector r is the initial point. So the change in final position to the initial position, change nothing but difference, right? So now we can write displacement vector p dash, or this one we taken as s dash, right? That is equals to vector r dash minus vector r. So this gives what? The displacement vector, right? So now displacement find out ಮಾಡಬೇಕಂದ್ರೆ initially first position vector. So normal one dimension displacement ನ ಯಾವ ತರ find out ಮಾಡ್ತಿದ್ವಿ? Here a b, ಯಾವುದೋ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ a ಇಂದ b ಗೆ ಟ್ರಾವೆಲ್ ಆಗಿದೆ, right? So a we taken as initial point, b we taken as final point. So displacement x is equals to final point minus initial point. So in the same way here also, so p is the initial point of the object, p dash is the final point of the object after it takes some time t, right? This gives what? The displacement vector. So r dash is the position vector, right? So if we taken s dash, so apart from this example, we taken this s dash is in this direction, right? So again ಆಗ್ತಿತ್ತು ನಮಗೆ from the triangle of addition, these two representing the two sides of the triangle, that means r dash vector plus s vector, that is equals to the third side is r, right? So displacement s is equals to vector r minus vector r dash. So there is a difference in r dash minus r to the r minus r dash. So direction is opposite to that of the displacement initially we taken, right? So ನಮಗೆ ಯಾವುದಾದರೂ ಆಬ್ಜೆಕ್ಟ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ, so in all the cases we need to plot the triangle of vector addition. So ಅದರಿಂದ ಈಕ್ವೇಷನ್ಸ್ ಬರ್ಕೊಂಡು next displacement ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಕೋಬೇಕು, right? So direct ಆಗಿ we can't write. So this is the displacement, right? So position, next ಏನಾಗಿದೆ, ಆಬ್ಜೆಕ್ಟ್ ಮೂವ್ ಆಗಿದೆ, ಅದರದ್ದು ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಬಂತು, ನೆಕ್ಸ್ಟ್ ಏನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು? ವೆಲಾಸಿಟಿ, right? So here we are finding the velocity, that one is the average velocity. So in the last chapter we discussed what is average velocity, that is change in displacement to the time taken, right? So change in displacement is nothing but initial final point minus initial point, just a vector agude, right? So v bar that is equals to delta, here displacement will be taken as s by delta t, right? So we know, yes. So ಇಲ್ಲಿ next r ತಗೊಂಡಿದ್ದೀವಿ, same wise r dash ಗೆ ಬರೀಬಹುದು ನಾವು, vector r dash that is equals to x dash I cap plus y dash j j cap, right? So these are the two position vector. So displacement vector. So displacement vector. So r dash, we can write this one as x dash I cap plus y dash j cap minus x I cap plus y j cap. Right? So first take down the displacement, next we will discuss the velocity. Right? So in coordinate system, displacement vector S is equals to, so subtraction of two vectors. So here we have I taken I as common, we can write x dash minus x I cap plus y dash minus y j cap, right? So this is the small change in position along x axis. We can write this one as delta x I cap plus delta y j cap. Right? So here we can write where delta x is equals to x dash minus x, delta y is equals to y dash minus y. So ನಮಗೆ ಎಲ್ಲೆಲ್ಲಿ ಡೆಲ್ಟಾ ಅಂತ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ಕೊಂತೀವೋ that represents what small change, right? So ಇದು small change, ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಆಗ್ತಾ ಇರೋದು small change, right? So here we represent distance ನಮಗೆ y, distance ನಮಗೆ x, right? So ಇದು ನಮಗೆ delta x ಯಾವುದು ಅಂದ್ರೆ x dash x dash it's not y, x minus x naught y minus y, so x minus x naught y minus y. So this gives what delta x. So this gives what delta y. So we do displacement, right? So displacement in terms of magnitudes and direction. So only displacement in terms of vectors, position vectors. In terms of position vector, that is r dash minus r. So in terms of magnitudes, delta x and delta y. So this gives what the change in displacement along x-axis, and this gives what the change in displacement along y-axis, right? So now velocity, that is average velocity. Velocity average, that is equals to change in displacement to the time taken, delta s by delta t, right? So we get it here, delta s, that is s is equals to delta x I cap plus delta y j cap. So substituting here, keeping delta s is delta by delta t. So in place of s, we are writing delta x I cap plus delta y j cap. So right, so here we get the average velocity, that is equals to delta x by delta t I cap plus delta y by delta t j cap. right? So this is what average velocity. So change in x-axis with respect to small time. So here I taken the small time delta t. That means change in x-axis to the small change in the time. That is the ratio of the displacement to the time taken. We call that one as the velocity. So we call this one as the average velocity along x-axis, and this one is the average velocity along the y-axis, right? So now the direction of this velocity. So idu namge magnitude bartide, right? So next direction of this velocity is in the same direction of the displacement vector, right? So displacement vector namge yav direction alli iruttho, direction of the average velocity kuda same direction alli, right? So this gives the direction of the v average, right? So average velocity is in the same direction of the displacement direction, right? Direction of the average velocity is in the same direction of displacement, right? So ನಮಗೆ displacement ಯಾವ direction ಅಲ್ಲಿ ಆಗ್ತಾ ಇದೆ, in the same direction ಅಲ್ಲಿ average velocity ಕೂಡ ಇರುತ್ತೆ ಅನ್ನೋದು it explains, right? So ನಮಗೆ different types of velocities ಇದೆ, right? So one is average velocity and the second important is the instantaneous velocity, right? So now if we discuss the instantaneous velocity, right? So what is instantaneous velocity? Velocity of a particle at that particular time. So ಯಾವುದೋ ಒಂದು particular time ಅಲ್ಲಿ ನಾವು ಆ particle's velocity find out ಮಾಡಿದ್ರೆ ಅದನ್ನ ಏನಂತ ಕರಿತೀವಿ ನಾವು instantaneous velocity. So average velocity means the overall displacement, that is the total displacement to the total we call as the average velocity. So instantaneous velocity is the velocity of a particle at a particular instant. That means if when t is equals to 1 second, now I am calculating the velocity of the particle. So in this time, if I calculate the velocity of the particle, then that velocity gives what the instantaneous velocity, right? So now here we are going to find the instantaneous velocity's magnitude and the direction of the instantaneous velocity, right? So for that we have all these things. So by plotting the same graph, here is x, here is y. So the particle starts from somewhere here, p, so somewhere here, p dash, right? So covering the distance from p to p dash, it takes some time delta t1, right? So the displacement is in this direction and the average velocity is in the same direction. So this gives what the average velocity. So iduna displacement vector barididini andre again by drawing the position vector, right? So here I am discussing only the velocity, right? So that's why I am using only the displacement vector, right? For example, ಈಗ ನಾವು some time t is equals to, that is delta t1, we taken some 10 minutes. So ಈ particle 10 minutes time ಅಲ್ಲಿ up to p dash ವರೆಗೂ distance cover ಮಾಡಿದೆ. So that one we taken as delta t1, right? So now we are decreasing the time. So next I am taken time delta t2, that is some about 5 minutes, right? So starting position ಇದೆ ಇರುತ್ತೆ. So 5 minutes ಅಲ್ಲಿ ಇರುತ್ತೆ somewhere here, right? So now if I draw the displacement vector, right? So then the direction of the average velocity is in this direction. When time is delta t2. Now restricting the time delta t3 approaches to 0 minutes, right? So we are decreasing the time. So time na decrease ಮಾಡ್ತಾ ಇದೀವಿ, displacement ಕೂಡ ಏನಾಗ್ತಿದೆ ನಮಗೆ ಡಿಕ್ರೀಸ್ ಆಗ್ತದೆ. ಸೊ ವೆನ್ ಡೆಲ್ಟಾ ಟಿ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು 0, ಸೊ ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ನಾವು ಏನ್ ಮಾಡ್ತಾ ಇದೀವಿ, ವೆಲಾಸಿಟಿನ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತೀವಿ. ಸೊ ನಾವು ಲಾಸ್ಟ್ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ಡಿಸ್ಕಸ್ v instantaneous is equals to limit delta t tends to 0 delta s by delta t. ಸೊ ನೆನಪಿದೆನಾ ಇದು? ಸೊ ಇದನ್ನ ಬರ್ಕೊಂಡಿದ್ವಿ. ಏನಕ್ಕೆ ಬರ್ಕೊಂಡ್ವಿ ಅರ್ಥ ಆಗಿತ್ತು ಅವಾಗ? ಏನಕ್ಕೆ ಬರ್ಕೊಂಡಿದ್ವಿ? ಸೊ ಏನ್ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡುತ್ತೆ ಇದು? When limit delta t tends to 0, that means as time approaches to the 0, then we get the velocity of the particle. So that particle we call as the instantaneous velocity. So here also we are decreasing the time, delta t1 to t2 then t3. So time decrease ಮಾಡ್ತಾ ಇದ್ದೀವಿ ಅಂದ್ರೆ distance cover ಮಾಡಿರೋದು ಆಬ್ಜೆಕ್ಟ್ ಕೂಡ ಏನಾಗ್ತಿದೆ ನಮಗೆ ಕಡಿಮೆ ಆಗ್ತಿದೆ. So direction of the velocity changes. So at this particular point when delta t is equals to 0, we get the velocity. Our velocity na ಏನಂತ ಕರೀತೀವಿ? Instantaneous velocity, right? So this velocity is in the direction at any point. If we draw the tangent on the curve, then that gives what? The direction of the velocity. So your velocity, so that one is the instantaneous velocity, right? So for example, ಯಾವುದೋ ಒಂದು ಪಾತ್ ಇದೆ, ಈ ಪಾತ್ ಅಲ್ಲಿ ಹೇಳಿದಂಗೆ at any particular time, so each time ಕೂಡ ನಾವು ಡಿಸ್ಟೆನ್ಸ್ ಕವರ್ ಮಾಡ್ತಾ ಇದೀವಿ, ರೈಟ್? ಸೊ at a particular time ಅಲ್ಲಿ ನಾವು ಫೈಂಡ್ ಮಾಡ್ತಾ ಇದೀವಿ ವೆಲಾಸಿಟಿ ಆಫ್ ದ ಆಬ್ಜೆಕ್ಟ್. ಸೊ ಇಲ್ಲಿ ಡೈರೆಕ್ಷನ್ ಆಫ್ ದ ವೆಲಾಸಿಟಿ ಆಫ್ ದ ಆಬ್ಜೆಕ್ಟ್ ಯಾವ ತರ ಇರುತ್ತೆ ಅಂದ್ರೆ when we draw the tangent at this point, right? So that tangent gives the direction of the instantaneous velocity. So here if I find the instantaneous velocity means here this gives the direction of the instantaneous velocity. So if here I am finding, so this gives the direction. So somewhere here means this gives the direction of the instantaneous velocity. So now tangent na draw ಮಾಡಿದ್ರೆ at any point on the path, that gives what? Instantaneous velocity. So that gives the direction of the instantaneous velocity, right? So magnitude find out ಮಾಡೋದಕ್ಕೆ again by the same, v instantaneous is equals to limit delta t tends to 0 delta x divided by delta t, right? So here we have delta s, right? So that one limit delta t tends to 0 delta x by delta t I cap plus delta y by delta t j cap, right? So ಇದನ್ನ ಬರ್ಕೊಂಡಿದ್ವಿ limit delta t tends to 0 delta x by delta t, we written that one as dt, that is in the form of differential, right? So same here, dx by dt I cap plus dy by dt j cap. So this gives instantaneous velocity, right? So that means instantaneous velocity along x-axis, that is equals to dx by dt, right? So instantaneous velocity along y-axis, that is equals to dy by dt, right? So this instantaneous velocity we can write v instantaneous or the velocity, that is equals to vx I cap plus v by j cap, right? That means we are replacing dx by dt with vx. Vx gives what? Velocity of the particle along x-axis, and vy gives what? Velocity of the particle along y-axis, right? So now the magnitude of v instantaneous, that means the magnitude of the velocity, instantaneous velocity, that is equals to under square root of vx square plus vy square, right? So and also if we find the direction theta, that is equals to tan inverse of vy by vx, that gives what? The direction of the instantaneous velocity. So there is a lot of difference in average velocity and to that of the instantaneous velocity. So average velocity is the total displacement to the total time taken. Instantaneous velocity is the at any particle at any time the position of the particle. If you find the velocity, then velocity we call that one as the instantaneous velocity. So ಇದನ್ನ ನಾವು ಏನು ಅರ್ಥ ಮಾಡ್ಕೋಬಹುದು, if an object is traveling in two dimension, so that particle has two velocities. One is velocity along x axis and velocity along y axis, right? So it covers the displacement in both x axis and y axis. That means it has two displacements, then two velocities. So problem ಮಾಡಬೇಕಾದ್ರೆ ಎರಡನ್ನೂ ಕೂಡ ಮೈಂಡ್ ಅಲ್ಲಿ ಇರಬೇಕು. Two velocities along horizontal ಕೂಡ velocity ಇರುತ್ತೆ, along vertical ಕೂಡ velocity ಇರುತ್ತೆ. So ನಾವು ಯಾವುದಾದ್ರೂ ಒಂದು ಫುಟ್ಬಾಲ್ ನ ಕಿಕ್ ಮಾಡಿದೀವಿ ಅಂದ್ರೆ ಆ ಬಾಲ್ ಅಲ್ಲಿ ಎರಡು velocity ಇರುತ್ತೆ, right? So this ball has two types of velocity. One is the velocity which is along horizontal and one is the velocity which is along vertical. So ಇದು ನೆನಪಿರಬೇಕು. So that's why we call this one as motion in plane, right? So next, same for the acceleration. So next is acceleration, or again by the same average acceleration, right? So average acceleration, that is a bar, right? So average acceleration is equals to change in velocity, that means delta v, that means change in velocity to the change in time, that is rate of change of velocity with respect to time. That one we call as the acceleration, right? So this is the average acceleration, so that's why we taken the average velocity here, right? So if I substitute here the average acceleration, so we get delta. So here v that is equal to delta v x I cap plus delta v y j, right? So that gives what? Average velocity. Again, if I substitute here delta by delta t as that of the velocity, right? So again, by taking the same example, here we have p, somewhere here we have p dash, so it covers some time, that is delta t. Displacement is in this direction, right? So displacement direction alli namge yav velocity irutte? Average velocity, right? So that one is v1. So next, average acceleration is also in the same direction of the average velocity. So in ಮೂರು ಕೂಡ ಯಾವುದು ಇರುತ್ತೆ ನಮಗೆ? Same direction. Displacement, average velocity and average acceleration. These are in the same direction, right? So now we are going to discuss about the instantaneous acceleration. This is ನಮಗೆ important. So now in the study model, maximum instantaneous velocity in terms of only if the given velocity means instantaneous velocity and instantaneous acceleration, right? Next is instantaneous acceleration. So instantaneous acceleration only we are finding the instantaneous velocity, that is change in instantaneous velocity to the time taken, right? So now so by drawing the instantaneous velocity at the point p, right? So if position ಅಲ್ಲಿ ಇದ್ದಾಗ instantaneous velocity ಏನಿರುತ್ತೆ, by drawing the tangent, right? So this gives what? V. So ಇದು initial ಇರೋದ್ರಿಂದ V ತಗೊಂಡಿದ್ದೀವಿ. Next, at this point if I draw the tangent means that is in this direction, that is V dash, right? So where V is the instantaneous velocity at point P in a certain time. So V dash is the instantaneous velocity at a P dash for that particular time, right? So now observe here, we need to find the direction of the instantaneous acceleration again by the vector law of addition, right? So what it says means change in velocity to the time taken. So first now instantaneous velocity, change in instantaneous velocity, that means V dash minus V. So ಅದನ್ನ find out ಮಾಡಬೇಕು. So ಅದನ್ನ find out ಮಾಡಬೇಕಂದ್ರೆ again by using the same triangle of vector addition. So drawing vector B as is, right? So now joining, that is B dash here as is in the same parallel. These two are parallel and these two are parallel, right? So we need what? V dash minus B, final velocity minus initial velocity. So V dash B, so we get what? V, that is V, right? So change in velocity V dash minus B ಬರಬೇಕು ಅಂದ್ರೆ ನಮಗೆ ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇರಬೇಕು? Result should be in this direction, right? So V instantaneous. If I apply the triangle of addition, observe here, V plus V instant, that is equals to V dash. So V instant, that is equals to V dash minus B. And the final velocity minus initial velocity. So that means the direction of instantaneous acceleration is in the direction of instantaneous velocity. That means change in instantaneous velocity. This one as delta V, right? Delta V represents what? Change in instantaneous velocity. So this gives what? Average, so instantaneous acceleration. So now if I take an somewhere here, this gives what? V dash. So again by the triangle of addition, V, so somewhere here V dash, again we are getting the instantaneous acceleration in this direction, right? So the vector instantaneous change in velocity of the instantaneous vector and to that of acceleration is always lies between 0 to 180 degree, right? So the angle between V and A is always in the range of 0 to 180 degree. So idu namage instantaneous velocity change agthodangala direction of instantaneous acceleration kuda enagtirutte change agthude, right? So in a particular direction anta heludukkagodilla. So that angle is changes from direction is changes from 0 to 180. That means the angle between V and A is always in between 0 degree and 180 degree. So e example alli direction of instantaneous acceleration is inwards, right? So idu nimage next concept alli artha agutte, right? So up to now just it is in the by using the triangle of vector addition, right? So this gives what? Instantaneous acceleration direction. So again for the instantaneous acceleration, that is equals to limit delta t tends to 0 delta V divided by delta t, right? So we need to write limit delta t tends to 0, so Vx delta Vy by delta t j cap. So this we can write dx d Vx by I cap plus dVy by dt j cap. So this gives what? Acceleration or instantaneous acceleration. So this in the form ax I cap plus ay. So now finding the magnitude of instantaneous acceleration, that is under square root of ax square plus ay square. The direction theta is equals to tan inverse of ay by right. So namage important yavadu andre instantaneous acceleration and instantaneous velocity, right? One maka represent ಮಾಡ್ಕೊಳ್ಳಿ. So centripetal acceleration ಕೇಳಿದಿರಾ? Centripetal acceleration. So ಈ diagram ಅನ್ನು ಹಾಕೊಂಡು just ಇದು by the triangle of vector addition ಯಾವ direction ಅಲ್ಲಿ ನಮಗೆ change in velocity ಇರುತ್ತೋ ಅದೇ direction ಅಲ್ಲಿ instantaneous acceleration ಕೂಡ ಇರುತ್ತೆ. So important formulas these three, right? So next here these are the acceleration. So here also we have two acceleration, One is acceleration along x-axis and acceleration along y-axis, right? So in a motion in a plane, we call that one as two independent or two superposition of motion along one dimension. That means ಎರಡು ಡೈರೆಕ್ಷನಲ್ ಆಗ್ತಿರೋ motion ನ superposition ಮಾಡಿದ್ರೆ, that means join ಮಾಡಿದ್ರೆ ನಮಗೆ ಸಿಗೋ motion ಯಾವ್ದಿರುತ್ತೆ, that is motion in a plane. So ಯಾವುದಾದ್ರೂ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಟ್ರಾವೆಲ್ ಆಗ್ತಿದೆ in plane ಅಂದ್ರೆ it has horizontal displacement, horizontal velocity and horizontal acceleration. So in the same time we get vertical displacement, vertical velocity and vertical acceleration. So we will do combine. So along x-axis we've only taken, that is motion in a straight line, want to be only displacement along x-axis, that means velocity along x-axis, acceleration along x-axis. So one dimensional ಮಾತ್ರ ಇದನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. So in the same way, freely falling body or body is thrown vertically upwards in a straight motion means we taken vertical acceleration, vertical velocity and vertical displacement. So in motion in a plane only simultaneous at a time we are considering the displacement along x-axis, displacement along y-axis and velocity along x-axis, velocity along y-axis. So we will do at a time now simplify ಮಾಡೋದ್ರಿಂದ so ಇಲ್ಲಿ ನಮಗೆ initial velocity ಮತ್ತೆ final velocity ಅಂತ ಇರೋದಿಲ್ಲ. So just the velocity, so that one is the instantaneous velocity. If we taken velocity initial velocity, that means v0, that is when t is equals to 0, right? So now if we write the equations of motion in two dimension, so initially we have s, that is equals to ut plus half at square, right? So this is the equation of a motion in one dimension. So if we write the same in two dimension, right? So displacement x is equals to v naught t, right? So v naught we call that one as the initial velocity, right? So plus half at square. So that means here acceleration is constant. So object is moving under the constant acceleration, right? So now displacement x minus x naught, that is equals to v0x t plus half ax t square, right? So x is equals to x naught plus v0x t plus half ax t square, right? So this gives what? The displacement which is along x-axis. So this is only the magnitude, right? So same wise y equals to y naught plus y0x t plus half ay t square, right? So these two gives what? The displacement magnitude which is moving under constant acceleration, right? So next, the second equation, v equals to v0 plus ax t, right? So initially when t is equals to 0, v0 is also equals to 0, right? So vx and this is vy is equals to v0 plus a by t. So these are the next two equations. Right. So the problem solve ಮಾಡಿದ್ರೆ idea ಬರುತ್ತೆ. So in the next class we will discuss with the new topic, right? Thank you.